Welcome everyone for this year-end review for 2021 for Apache Pinot. Super excited to have all of you here. My name is Kishore Gopalakrishna. I'm one of the co-creators of Apache Pinot, and we have a lot of other contributors here who helped us a lot in terms of getting us to this place. One of the biggest news of 2021 for us is really the graduation in the ASF. Again, ASF has a bunch of requirements for a project to actually graduate from incubation to top level. And this was one of the very good achievements for us. We have done a lot of work along with the community's contributions here to graduate to this. And again, this was not possible without all the awesome people who contributed for the last 4 or 5 years. A very cool logo that kind of shows the graduation hat. And we have a lot of folks here as well who have contributed to this. Really awesome to have such a really good community here continue to contribute. Again, a little bit in terms of the numbers on how quickly we have grown, and especially as you see, the project itself started way back at in LinkedIn in 2015, 2016 timeframe. But in the last 2 to 3 years, the community has really taken off, and the project has achieved a lot of big milestones. And we just got to know that just yesterday, or was it probably today, we just reached the 1 million download. And if you kind of look at it, early this year, we had like 50,000 downloads, and the project is growing at a rapid pace. And we have 1 million downloads now. And even the community is very strong. We are almost close to 2,000 members in the Slack community. We have doubled the contributors. We had 100 plus last year, and we have like close to 200 people this time. Overall, we are seeing huge growth in both the contributions that we are getting to the project as well as adoption as well. On the companies, again, there are a lot of really good companies with very high scale adopting Pinot. Again, as you know, there are a lot of projects in the space, and it's really good to see all these companies adopting Pinot. LinkedIn, Uber, 7-Eleven, Confluera, Walmart, they're all taking up Pinot as one of the most critical piece for their infrastructure, and being able to provide analytics both to their internal users and also their external customers as well. Those of you who don't know, if you're using LinkedIn, you're accessing Pinot in some shape or form, right? Any number that you see on LinkedIn, whether you go to Who Viewed My Profile or your feed, you are querying Pinot behind the scenes, right? And again, these numbers are insane, 20 billion plus records scanned. Similarly at Uber, they're growing a lot. Lot of different systems are power applications at Uber are now powered by Apache Pinot. If you open a Uber Eats app today, and if you see orders near you, you are actually making a query to Pinot, right? And so there are a lot of such cool things that are happening, a lot of user facing and also internal analytics that are powered by Pinot. Again, 800 million records per second, 1.6 GBs and 30K queries per second. So these are like really impressive numbers. And again, Uber continues to push the boundaries of Pinot along with LinkedIn there. Stripe just, most of you might know, started using Pinot last year, but their scale has been enormous, and it's almost at the verge of overtaking both LinkedIn and Pinot to some of the scale numbers. It's really big. They already have like 1 petabyte plus data size, counting to 1 trillion rows. Almost every transaction is getting, Stripe is getting stored in Pinot, and they're able to achieve sub-second latency on this at this scale. Again, a lot of impressive work. If some of you want to learn more, there was a Kafka Summit talk earlier this year. I encourage all of you to attend that. There are a lot of good details on how they were able to achieve this. With that, we'll get to the 2021 accomplishments that has happened. At a very high level, if you kind of look at Apache Pinot, right? So it's a system where it's not the source of truth, because it generally ingests data from other sources. And a lot of things that we focus on is how to make the ingestion easy. What are all the different formats that we want to support? As you see, there are, when at LinkedIn, it was really Avro. That was the only format that we started off. but we have added a lot of new data formats: thrift, protobuf, parquet, JSON, CSV, ORC, many more to come. The pluggable architecture of Pinot helps us to add all these new formats very quickly. At the same time, HDFS was one of the sources that we used at LinkedIn, but now we have support for S3, Azure, and DCS as well. Streaming sources, Kafka, as you know, is very, very popular, and that was one of the first sources that was supported. But we'll talk about this in detail. We had to make some changes here in terms of the pluggability, and we were able to add Kinesis and Pulsar, and PubSub and Event Hub is something that we are working on. Last but not the least, most of the time, analytical systems catered only to the immutable data, or rather append only use cases where the the records data doesn't change. But thanks to Uber, we have the Upsert ability in Pinot now, which means you can mutate the data on a record level basis, not at a segment level or at a daily level. So each record can actually be updated. And this has opened up a lot of use cases for Pinot. You can simply point at a database via Debezium connector, start getting the data into Pinot, and then start querying it immediately. So a lot of cool things happening in the ingestion space, and we continue to invest heavily in increasing the coverage here on different sources. Again, if you're using something else that's not here, feel free to put it in the roadmap link. We will definitely make sure that we handle it in the next year. Again, on the Apache Pinot side, a lot of things, as you all know, one of the secret sauces behind Pinot speed is really indexing. We have added a lot of different types of indexing over the last year. JSON, we also had the Lucene index, and we are trying to replace that with the native text index, which is showing a lot of performance improvement overall, and also in terms of the memory consumption. We also improved upon the range index v2, saw some really significant performance improvements there. Last but not the least, the Geospatial allows you to now simply ingest the geolocation data, and based on lat long, you can do very cool queries, so as how many orders are near a particular zip code. We did a bunch of stuff on the tiered storage. A couple of things, exciting things that is coming up here is the ability to support nested data structures / complex data types as well, and also improve the compression on the storage side. We added one of the most popular requests from the community was to support segment merging and rollup. So this is a background task that continuously runs behind the scenes, organizing the segments on a daily basis, or even adding more indexes, optimizing the segment format. So a lot of performance boost that comes with this. It's based on the Minion framework behind the scenes. On the query layer, we added, as we are slowly moving from the single table query to multi-tables. So lookup join is a first step in that direction. So now you can actually do lookup joins with dimension tables, and that supports a lot of different types of use cases, so that you don't have to denormalize everything. We are also moving more towards the standard SQL. So we are replacing some of the features where we had UDFs in the where predicate to support things like like and other regex features directly in Pinot. A few other things in terms of the UDF. So the typical philosophy for us is like we always start with the UDF before changing, making the default change as how the SQL standard behaves. So we have added a lot of features here: JSON, time, Groovy. Be careful when you're using Groovy. Again, with the recent Log4j, security is definitely important. So know what you're doing with that feature. I would suggest turning it off if you don't really need that feature. But it's very, very useful because it helps in terms of just writing your own custom function without having to understand Pinot internal details. And once you get the functionality right, then you end up going and writing your own UDF. So it is definitely useful, but be careful when you're using something like that. Last but not the least, it's really the app section. I mean, this is why Pinot has become very, very popular, because of the way the way Pinot is used, and in terms of providing functionalities to your end users, right? And it's typically done via apps, and these are user-facing applications. Things like Third Eye, which is anomaly detection, and RCA. It's also used in internal BI. So a lot of personalization, log analytics. So these are all really good applications where you can actually use Apache Pinot. We also understand that there are a lot of other ways of accessing this data, and Presto, Trino, Superset, other JDBC connectors. So these are all the visualization apps. And again, Presto Trino also provides some of the missing functionality in Pinot, which is like joins, and it also helps you to join data from Apache Pinot to like MySQL or Postgres or any other system. So we continue to invest heavily in all these connectors, both on the inbound connectors where we get the data into Pinot, and also the outbound connectors where other apps can actually consume this. So overall, this is how we look at the entire stack as, and we have done again a lot of good things here over the last year, and we continue to invest heavily in along all these areas. With that, we'll get each individual person to talk about the features. Again, a lot of these came from the community. We couldn't have gotten here without the contribution from all these folks. Will be really cool to see them talk about the features that they've added and what kind of difference they have seen in the community and the use cases, both in terms of improving the coverage of Pinot and what new things that it can do. Also the performance improvements as well, which results in huge efficiency gain.
Yeah, so hi everyone, I'm Jackie, and then I'm PMC of one of the PMC of Apache Pinot. So here I want to briefly introduce some new features and enhancements we made to Pinot in 2021. So back in 2020, we introduced the JSON index, which can basically allowing filter on JSON objects. And then in 2021, we enhanced the JSON index to support mutable JSON index. Basically, that allows people to use JSON index in real-time consuming segments. So basically, there's no performance difference between consuming segment and offline segments. And then we support the JSON path syntax. So as shown in the query. So we also use the $sign. And then with the JSON path syntax, we're able to support the indexing the nested JSON array. So basically, there's no limitation on how many level of nested array supported in JSON index. So in the example, it shows a 2-dimensional array, but actually right now we are able to index 3-dimensional, 5-dimensional, unlimited nested JSON array. Okay, so the second feature I want to introduce is called derived column. Derived column is the column derived from other columns where the ingestion transforms. So the support we added here is we allow generating the derived columns during segment load, so that derived columns doesn't need to be can be added on the fly. So there's no need to re-index the whole data in order to get a new column. So for example, here we have a new derived column called or since epoch, which is simply derived from millisince epoch. And then this feature allows us to add a pre-materialized column to improve the query performance. For example, we want to do a group by on or since epoch. With derived column, we can store a physical column of or since epoch without using UDF, which involves some unnecessary overhead. Next slide, please. Yeah, so besides that, we also add the timestamp and Boolean data type support. So these two data support are supported natively right now. And then I just give two simple examples where these two data types are used in filter. They can also be used in transform, projection, group by everywhere. So yeah, basically this query shows the format we are taking. And then last but not the least, we add a query thread quota, where we allow users to configure the maximum number of threads used for each query on the server, so that one expensive query won't exhaust all the system resources and then cause all other queries to hang or like the server, bring down the server. So in the graph, we can see like the first 3 queries, basically there's no thread limit. So it uses almost 100% of the CPU. But once we like enable this thread quota, the CPU usage just dropped to about 20%. That's all from me. Thanks.
Hi, I'm Richard. I'm a software engineer at Startin, and I'm based around Oxford in the UK. So the first feature that we added was V2 range index. The purpose of the V2 range index is that the index with the best kind of space-time trade-off that you could have is the sorted index. And if you've got a reasonably good range index, then you can use the sorted, you can set the sorted column to something other than time. So the idea behind the range index was that basically it should be good for timestamp columns. And it'll work on any kind of numeric or dictionarized column. And we got really good performance improvements from it. So on this particular example here on the complex website, kind of example, which is in the Pinot source code, we got like a 6x improvement, and we've seen 5 and 10x improvement on the old range index. And so it's available in 0.9, but you have to configure it by setting range index version to 2, and then it's going to be the default in 0.10. So if you really have range queries which are slow, then consider enabling it now. The next one was the kind of the V4 raw index, which is basically designed for like really variable length data. So if you have things like JSON or kind of text that you want to search, and it's got some really long records, so there's a really fat tail to the distribution. What that would do, before we would have to estimate based on that length how much how large a buffer to allocate, and allocate too much memory in some cases. And so V4 kind of solves that by not having a fixed number of documents per chunk, and having a variable number, and it means that there's we basically have a constant amount of memory allocated for consuming data, so it should reduce memory consumption. You have to configure it with field config, so you'd have to set raw index writer version 4 down here on the field that you want to do this on, and yeah, that's how you get that, and that's available in 0.9. We also found that LZ4, this basically builds on something which I think is going to be discussed later, but basically you can have new compression modes, and we found that and that was done by LinkedIn, but that LZ4 is basically faster to decompress than Snappy, so we changed that. So from 0.10 onwards, it's going to be LZ4 compression, which is going to be really good for decompressing raw columns. And the good thing about working at Startin is we see lots of people who have very disparate use cases for Pinot, and so it's amazing some of the things that turn up when you connect a profiler to Pinot kind of in a new use case. And so hopefully the accumulation of these kind of profile guided and performance improvements will be noticeable in 0.9. That's about it for me. Thank you.
Hi, folks. My name is Subbu. I'm one of the PMCs in Pinot. I work for LinkedIn. One of the features that we added was segment merge rollup task. So you can actually configure this on your real time on your offline tables, where you can compact the number of the segments on a time bucket basis and aggregate data for longer time periods. We have seen use cases of this when we have both smaller low resolution time data for near time periods for the first week or so, and after the week we want longer time resolution or a finer coarser time resolution for much longer periods for capacity estimation and so on. Next slide, please. Some of the other features we've added are broker level pruning for time columns. It used to be that all the time column was not considered in terms of pruning segments on the broker side. So now we have basically moved from basically have the broker prune the segments that do not match the time filter in your query, and that has speeded up query performance significantly, because a lot of segments, if you query within time range, they're not even considered for query anymore. We added explain plan feature, where we have you can type explain with the query, and then it's going to walk you through the physical and the logical plan that Trino has for that query. We added more compression types to support raw index. We have query CPU time measurements. We are using those internally for capacity estimation, as well as for debugging purposes. They can certainly be used for debugging purposes at this time. The capacity estimation part, once we have the algorithms clear and once we have the results, then we expect to publish that in the open source as well. We've added server level segment pruning for the in clause using both min-max statistics as well as Bloom filters. These significantly reduce the scan that we need to go through the server side when an in clause is added on the query. Performance optimization for simple straight select queries without transform functions. We added compatibility testing framework that allows us to, or allows anybody before rolling new Pinot release to test its compatibility with your existing data. So you can configure this with your own data and your own set of queries and make sure that the new release that you're going to upload, that you're going to update to, it will still work in your use case. We have a compatibility tester there with some tests, and that will be automatically tested when Pinot is released. We added TLS authorization for broker to server, the NEDI using NEDI TLS. And lastly, we added declarative access control in the REST points. This is more for the contributor standpoint, where you can add new REST endpoints on the controller just by declaring the authentication type, as opposed to individually deciding which one is to be authenticated at a table level or cluster level, and so on. Next slide, please. Yep, that is probably Yupeng.
All right, thanks, Subbu. Hi, everyone. I'm Yupeng from Uber. So I will talk. I will highlight a few contribution from Uber this year on behalf of the Pinot team at Uber. So over the past years, we have seen like significantly increasing interest in Pinot at Uber. And along the way, that motivated us to make several contributions on different fronts. So this slide talks about the geospatial support. Like, the Uber's business by nature is highly relevant to the geolocations. Our mission is to put the entire world into motion. So if you open your like Uber Eats app, if you use Uber Eats, then you can see one interesting feature is to show the popular orders around you. So this is served by Pinot, and it's a very good example of how we use the geo information inside Pinot. It's actually pretty straightforward from the SQL query perspective, that you can use a standard geo query, which starts with st_, and to select orders within a given distance for particular data points. What's cool here is that we not only introduce this geo data type and functions, we also contribute a geo index, which can significantly improve the performance. As you can see in the diagram below, that if you want to retrieve orders near some San Francisco area, with the GeoIndex, you're able to only retrieve relevant order information within the hexagon nearby, but not necessarily scan all the orders across the entire world. So if you're interested more in this geospatial, we made a talk this year. You can read more in the YouTube video. Next slide, please. No, last year Uber contributed Upsert to Pinot and becomes very popular both inside and outside Uber. This year we made several improvements over Upsert. For example, we allow the direct segment push to the real-time Upsert table while making iterations over that. This slide highlights another interesting improvement, which is a partial Upsert. This has become very convenient for the table owners that when you ingest the update information, that it allows you to only specify the columns that's updated and keep the others ignored. Like for example, like in the Uber case, we can have the events like represent some adjustment to the ride share. For example, the tips. Then for these updates, we can safely ignore the other columns. What's more is that we provide multiple inbuilt strategies to cover most common partial Upsert logic. And we're also working on a Groovy-based script that can give you more power to customize logic of the Upsert logic. Next slide, please. Another interesting contribution we made this year is to bridge the Pinot data model and the complex data models such as in Avro or JSON to handle data structure like arrays and structs during the ingestion. So there's already pretty cool JSON index support contribute into the open source. For this one is to cover some scenarios that people need to have like native data format for some fields. For example, if you want to group by some nested field, this gives you a way to extract this field out as part of ingestion. And this saves a lot of efforts for people building a streaming processing pipeline for manipulating the data on the ETL part. Inside Uber, this is actually pretty popular for the table owners because they save tremendous work from their side. You can read more about this feature on how we manipulate the complex type transformation in the documentation at bottom. Next slide, please. Last but not least, we also made a good contribution on the Lookup join. This is another popular demand we have seen at Uber that people want to decorate some existing Pinot table with additional fields from other dimension table. So for example, in this query, people want to retrieve and do analysis of the restaurant orders. But because the order information is denormalized, that each event only carries the restaurant UUID. To make the results readable, this lookup join can allow you to decorate query results with additional information. And in this example, we decorate the name and the country of the restaurants, and we can calculate the revenue for the open restaurant of a given day. So today the lookup join only applies to a small dimensional table, And we do this by replicate this dimension table to all the servers to enable the lookup. And we have seen more as on different types of joins. So the join is actually one of the active development area right now that we're looking forward to more contribution on this for the upcoming year. You can read more about this lookup join at the link at the bottom. And that's the rest of my part. Thanks. Next slide, please.
This one's me, so I will. Thanks, Yupeng. That was pretty impressive list of contributions from Uber and from your end. So I'm going to talk about the new real-time stream plugin that we added to Pinot this year, and that was for the Amazon Kinesis stream. And this is super useful because now people who are using Kinesis, earlier they would have had to set up Kafka also in their cluster and then have some pipeline to kind of transfer their events from the Kinesis stream to the MSK that they've set up. So use like a Kinesis Kafka connector and then additional operations and then also additional cost for operating Kafka. But now with the Kinesis connector, they can natively just ingest events from Kinesis directly. So we were able to, and again, like Kishore said, this is kudos to all the people who worked on Pinot until now. It was not the most straightforward, but pretty easily we were able to make some changes to just get the Kinesis plugin fit into our low-level stream architecture. So this is how you would go about using a Kinesis stream now. You would just, in your stream configs in the table config, specify stream type Kinesis, and it fits into our low-level consumer type. You provide the topic name, and then this class, Kinesis Consumer Factory, that is the entry point for all the Kinesis magic that's happening in the Pinot code. And then some Kinesis specific properties like the region and access key, secret key, or if you don't want to use the basic credentials provider, but instead go with the role-based, you can use the default credentials provider or anonymous credentials provider. There's a bunch of options to go about how you want to provide your credentials here. And then similar to how we had the offset criteria in Kafka as latest, earliest, in Kinesis, we provide the shard iterator type. So there's latest, or if you want to go earliest, you would provide something like at sequence number, after sequence number. So a bunch of options there. And so while this Kinesis was pretty much quite similar to Kafka, there were some key differences because of which we had to refactor and rethink a little bit of how our real-time stream ingestion driver works. So one of the key differences was the way we have partitions. In Kinesis, we have shards. But in Kafka, the partitions can only ever just keep increasing. So if you started with 2, you could go to 4 and then 8, and you're never going to reduce them. But in Kinesis, we had the concept of splitting and merging shards. And how that worked was if you started with shard 0, and now let's say you had more events per second coming over, so you wanted to increase your partitioning. So you would go about splitting shard 0, and you would now have shard 1 and shard 2. But that meant that shard 0 is no longer active and it will never be active again. So it's effectively reached its end of life. And similarly, if you had to merge shards because your ingestion rate is now lower again, so shard 1 and shard 2 can be merged and it will become shard 3. But that means shard 1 and shard 2 have reached their end of life. So we had to make some changes to handle this specific behavior. So now we do support the concept of a shard or a partition just totally retiring for the rest of the stream ingestion. And also one interesting thing was because of this nature of 0 becomes 1 and 2, and then 1 and 2 becomes 3, this sequence, there's like this natural sequence between how the shards come up and go. So we had to take into account that when we begin ingestion, we always start with the order in which they're appearing and disappearing. So we had to make sure that we start with 0. Only when we're done with 0, we go to 1 and 2, and so on. This has been detailed in this documentation, for the link for which I have added to this slide. So that's it from me. Thanks.
Hi folks, this is Atri, and I'm a distinguished engineer at Securonics. And I primarily work, before Pinot, I've worked with multiple different databases. I'm also pretty familiar with the Lucene and Solar engines. So I want to take an opportunity to talk about the native text indexes and the like operator support that we're working on. So recently, and I've been focusing on building, all of our text indexes and FST indexes today are built into off Lucene. And the problem there is that Lucene is a generic search engine library, and we don't really have the potential to control a lot of stuff that goes on there. For example, we don't have real-time streaming FST support, or we don't have the ability to short circuit prefixes, because that's what Pinot really cares about. So native text index, native FST and the native text search library was introduced in Pinot, and then FST index was introduced on top of it. Concurrently, the like operator, which is defined by SQL standard, was recently introduced in Pinot as well, and it uses the FST indexes available, and it will soon use the Lucene text index as well. So the idea here is to eventually move to a native text index model, which is SQL standards compliant. Right now, we have the native FST support done and ready and committed to the master. And like operator performance tests on top of it, compared to same like operator with the same data, running on one segment on with native FST index, one with the Lucene FST, shows a performance improvement 25 to 50% over I think over 50 to 100 runs. The performance benchmark is a part of the Pinot micro benchmarking library. Please take a look at it. It can be enabled by setting index type equal to native for FST indices, and there is more work coming in this direction right now. Next step in this was in-memory FST, which will allow real-time text search to happen as data comes in. We will not require segment flush to happen. We can search for data that's already present and have full text search capability on top of that. And the next, then we will be proceeding with more complex search queries, such as phrase queries and fuzzy queries. So yeah, that is basically the work that is happening for native text indexes and the like operator. The other thing I wanted to highlight, which was releases the last Pinot release, is a dictionary-based query execution plan for distinct. So distinct typically does not use dictionaries for query execution, which is a performance gap that was seen by many of our users. So now distinct can actually utilize the dictionary under certain predicate constraints. And it's automagical. The query planner takes all those constraints into account, looks at the query structure, and uses a dictionary-based plan if applicable. Again, there are no configuration changes required, and the query planner is intelligent enough to handle all of this. On queries that are able to use this query plan, before and after performance test led to a performance number of around 20 to 40% on a data set of about 4 million documents. And that purely comes with the fact that dictionaries are much more faster than a full scan. So this feature is already committed, and this is one step further in the direction of having Pinot's query optimizer be more and more intelligent and have the ability to dynamically plan different kind of execution paths for the same query based on query structure and eventually even more parameters. That's all I wanted to highlight for today. Thank you so much.
Hi, I'm Elon Azoulay. I'm a software engineer and I work on the Trino Pinot connector. We use it heavily at Cloud Kitchens and production where I work. Yeah, this is just a basic overview. There's two modes. One where if there's no aggregations, it will do server queries, and we actually have a pull request to use gRPC streaming. We actually use it by default in our production, and it works perfectly. And then the other mode is a broker query, which either if you do aggregation pushdown or a pass-through query, which I'll briefly explain, the query will go to the broker, and pushing down aggregation can turn a query that takes, like seconds or even minutes down to milliseconds or seconds. And we recently landed changes to support Pinot 8, and the connector, judging just from the user comments, also works for Pinot versions greater than 8, but we're working on updating it to be compatible with 9 and 10. Yeah, if you can go to the next slide, please. So this was the major change, was aggregation pushdown, which if you do a group by at night, we can support complex group by and other expressions. It'll convert the query into a broker request, and then instead of aggregating in Trino, it'll push the aggregation to the broker, which was for us a major win in terms of performance. Yeah, and then next slide, please. So this is, the syntax looks a little strange, but this is the way that you can push down an entire query into Pinot. And so you can do anything in between the quotes. Just note that it's automatically lowercase due to the way Trino parses in the SQL standard, but we actually added some smart uppercasing. For example, if you do a date trunk or lookup join with a certain field, it will automatically uppercase the time unit. And if you want to pass an uppercase constant into a filter, we implemented pushdown, so you can put the filter outside of the double quotes, and then it'll push the value in with the case that you defined it in the query. That's a brief overview for that. And yeah, the next slide. Oh, that's it. Yeah, so the main thing we're working on now is Pinot insert, which we use the segment mapper API from the Pinot code, and where we have a pull request, which we'll be updating and work with the community to make sure everyone can use it.
Definitely. Thanks everyone again for talking about all the features. Again, it almost feels like it was yesterday that we did our 2020 year in review, and time flies really fast, but looking at all the features that people contributed, it does feel like a really long year. I mean, that was awesome work across the entire community, and really good to see this. Again, I want this next section to be really coming from the community here, because this is how we had a very, very good 2021. We did something very similar. We put a poll for the community last year, and it was actually quite surprising, and it was also satisfying to see that a lot of features that the community asked for was what actually drove the roadmap for 2021. And we are kind of following up similar strategy this year as well. So Karine has already posted the poly link. Please take a minute.
Share it again as well.
Yeah, yeah, I think that would be great. Take a minute, take a look at it, and then see if you want to add something. And it's always surprising that you just add and then others come and just upvote it, and then we can take it up and make sure that's part of our 2022 roadmap as well. Any questions on the features before we move to the roadmap? Feel free to put the questions on the chat as well. And again, as you all know, there is a Slack channel. Feel free to be part of that as well, and if you have any questions there. So quick recap in terms of how we have been thinking about the vision for Pinot itself, right? And if you kind of look at the overall design, initially it was made with a strong idea of storage and compute being tightly coupled, and this was for valid reasons in terms of achieving very, very low latency even at high throughput. And then we also started off the project with the assumption that once the records come in, they don't get updated. So that's what immutable record was. And structured data was another part of our initial design requirement. We wanted to make sure that every field has a very strong data type associated with it, strongly typed, and has a data type associated with it. And last but not the least, we always restricted Pinot to support only a single table query, right? The queries were never able to span multiple tables. But as we see more and more adoptions and more things coming, and people are getting addicted to the speed that Pinot provides, they want to do more things on top of Pinot. And luckily, one of the things that has happened in Pinot is the architecture has been really flexible, and we luckily or unfortunately we got some of the architectures right in the beginning. So it helped us make all these pluggable things pluggable and also extensible. So that's kind of what our vision is, right? So to go from all these restrictions and kind of open it up so that it helps us achieve more coverage and also not compromise on the speed. So the first thing there is the storage and compute. So we will be working on decoupling this tight integration between the two. So there is a lot of work that's going on in the SPI already to make sure that we have a very strong spec laid out so that the local and the remote can work independent of each other. But at the same time, you can have a table in both modes where you can say something like, for the last 7 days, I want the storage and compute to be tightly coupled because most of the people query during that time. And for any data that is beyond 7 days or 30 days or 60 days, whatever your use case requires, you can say, I want it to go directly to S3. And this allows you to get the best of both worlds, which is like very good performance for the recent data. But at the same time, a very high efficiency for the old data, right? So, and this is natural, and the things that are happening in the cloud with the bandwidth increasing between the storage and the compute, remote storage, actually allows us to do some of these things. The second high-level theme for us is really stop the go beyond immutable records, right? And as part of this, we are also thinking in terms of adding a write API, because as you all know, Pinot is more towards ingestion or a derived source, which is point at a source and we actually pull the data into Pinot. So not only being able to update the records or update the data at a record level, but we will also provide write APIs on top of this. The structured data is another one, as you all know, as more and more data comes into Kafka and all these other streaming sources. The data is not really structured. I mean, it's kind of semi-structured and deeply nested, and some of them are like completely unstructured as well, which is the text, right? So we want to kind of go to the semi-structured as well. And there are already things that are happening in terms of JSON indexing, text indexing, which is kind of taking us beyond the concept of structured data. So we have semi-structured and unstructured support already, but we will continue to enhance, improve the efficiency in how we are storing this. The key thing to note here again in all of these is we want that concept of flexibility to be there across all these features. So if you kind of look at structured and semi-structured or unstructured, one of the beautiful things about Pinot is every column can actually be either structured or semi-structured or unstructured. So it's not really at a table level. It can even go at the granularity of a columnar level. And that's a very powerful feature. It lets you do a lot of build amazing applications where you can say, hey, some of this data is not accessed often. So it can be in a semi-structured model or even in an unstructured column. But as soon as you need some very good performance on that, you can actually create a derived column from that semi-structured or unstructured data, and the performance will be really good. So having that capability is really amazing, and it lets you use one system as your workload requirements changes instead of continuously moving from one system to another. Last but not the least, one of the most requested features for Pinot is going beyond a single table. So multi-table, and a lot of people achieve this through Pinot, so Presto and Trino integrations, and Spark connector is also another one that is coming. While that is really, really good, there are still a lot of enhancements and performance improvements that we can do by supporting joins natively within Pinot. So this is going to be a big change. Given it's not trivial to simply go from a single table to a multi-table. But again, given the architecture and given the SPI we have in Pinot, this is something that is feasible. And this is another thing that we will be focusing on. One of the big things I would say as part of 2022. Please let us know if there is anything else that we are missing here in terms of the big topics. We will definitely feel free to look into it. This is kind of, I don't want to go into the details of each and every one. This is almost like the things that we had thought about from the community and whatever the inputs that we have gotten so far. But as you see, there is a poly link on the top. Feel free to take a look at that and then go ahead and add your request, and please upvote if you see something that you would like to see in your company or you would want to contribute as well. Again, all of this, we actively welcome contributions from everywhere. We have a very active Slack channel. Feel free to even brainstorm the ideas with us. Happy to do that. And again, we kind of broke it down into different things in terms of query, operations, ingestions, connectors, and documentation. So these are the high-level themes in terms of how we have classified some of the feature requests in this poly link. Feel free to add more. And that's pretty much what we have for today. Yeah, that's pretty much. Again, thank you so much for joining us. We kind of a little more than an hour, but thanks again for everyone for staying back. Feel free to ask questions if you have any. But again, request you all to take a minute or two to go to the poly link and then upvote or add more features there. Again, any thoughts in terms of anything that we can improve in terms of the community is also very welcome. We care deeply about the community and we want participation from everyone across the community as well. That's it from me. Thank you.